So for today's problem, we are looking at the integral of, cosine 3x dx. So before we begin, we should probably understand what antiderivatives are. Now we're probably used to deriving things, f of x, f prime of x, and f double prime of x. To go from left to right, we take the derivative. We derive, d over dx. That's how, taking the derivative of f of x gets you f prime of x, and taking the derivative of f prime of x gets you f double prime of x. So what happens if we want to go the opposite way? What if we want to go from f double prime to f prime, or f prime to just f? In that scenario, we want to antiderive. Or they sometimes also call it integrate, because they call it an integral. So that's why we can often apply the rules that we learned for normal derivatives to antiderivatives. Like how the derivative of sine x is the same thing as cosine x. With that rule, therefore, the antiderivative of cosine x dx will equal sine x. Alright, so let's look back at the problem at hand, which is this thing colored in blue. Normally, we could be like, antiderivative of cosine x, that could get us just sine x, right? Wrong, because we have a 3 here. And because of that 3, you cannot integrate this easily. And when you cannot integrate something easily, you have to use U-substitution. So let's do it. In this case, our u is going to be 3x, because it's pretty much our innermost function. We take du, or the derivative of our u, that will get us just 3 dx, because the derivative of 3x is just 3. But because we're looking at du, or because we're using u substitution, you have to add a dx at the end of that. So we can actually start rewriting our equation with our u terms. Squiggly line, or integral, cosine, no longer 3x, but u, and then, something's wrong, because I need to replace d of x, but there's no 3 in front of it, unlike what our du has. That means we have to take this part a little further and be like, okay, I just want dx. I want to isolate dx. And I can do that by dividing both sides by 3. I'm going to write it as 1/3 times du, just for simplicity's sake in the future. Because 3 gone. 1/3 stays on the left hand side with du. Now we have dx by itself. So we can just kind of plug that in for dx now, 1/3 du. Between steps, you typically want to see if you can reorganize the equation in a way that makes things a little easier to read, like moving your constants outside of the antiderivative, because constants that are antiderived don't actually change. So 1/3 is a constant, so we're going to move it outside of our squiggly line, but everything can stay. Now we can actually do the fun part of antideriving our function. Right, yeah, we can antiderive our function now. So since we can't simplify it even further. So write down what will stay the same first, because you cannot forget it, times the antiderivative of cosine u du. Well, just like I was saying before, because we know that the derivative of sine x is cosine x, then the antiderivative of cosine x dx is sine x. So we can just rewrite sine u, and then because we antiderived it, that squiggly line goes away, and the du goes away, and they get replaced by a plus c at the end. Never forget your plus c. It's very easy to forget. Now we can, now that we antiderived it, we can do the last and final step, which is substituting our u with our actual x. So 1/3 sine 3x, because that's what we solved for initially, plus c. And that is your answer.